Alright. These are properties of logarithms. We have three properties we're looking at, and all the problems are going to be a combination of these three properties. The weird thing about this is you're changing this property to addition. So here I have a log of a times b. That a times b is going to be changed into two logs, two separate logs with an addition between them. When we have a quotient, it's basically a fraction. If you have a fraction, so fraction quotient is going to be synonymous here. So when we write that fraction, we're going to write it as a subtraction. So product is addition, fraction is subtraction. When we have an exponent, so the power property, we have an exponent. So here, b is the exponent, right? It's an exponent on something inside the logarithm. That's going to come forward as a coefficient. So I'm going to do a bunch of examples that use this combination of these rules. All right, so the first one is just a product rule. So we're going to change this product to addition. So this would be log base 2. So this is 5 times x, so it becomes 5 plus, it came from there. It's part of the problem. Log base 2 of x. That's it. So these are rewrites again. So there's no calculations here. I'm not expecting you to figure out anything like 6 to the 4th, like this third example here. Right? I just want you to rewrite this using the properties. So this is a fraction, so it's going to turn into subtraction. So it's log base 5 of 12 minus log base 5 of 7. The base has no effect on our problems today. The base has no effect on our problems today. So just copy it. Just copy the base. All right, so this is an exponent. So the exponent comes forward as a coefficient, and then you just copy the rest. Log base 3 of 6. And that's that one.
Is that times by log?
It's 4 times log base 3 of 6.
So we don't write the times?
You do not. Are you talking about this dot? You do not have to write that dot. All right, ready? Waiting. Ready? Waiting. It's okay. I'll point to the videos and see. This is what Tyrese does in my class. He just runs his mouth. All right. Oh, remember this is being recorded. All right. All right. Let's zoom in a little bit. Okay. So, do you remember what exponent a square root is? What exponent is a square root? Well, all I'm going to do is rewrite that square root as an exponent first. So square root is 1/2. All right, this is the one place, if you don't see a number, you assume the number is 2. And that's going to be the denominator of a fractional exponent. Now, since that's an exponent, you're going to bring it forward as a coefficient. So it's 1/2 log base 6 of 17. That's it. That's all I am asking you to do. Now the class is unusually quiet. B. Yes, the teacher's the biggest distraction. All right. Now, log base 2. I'm going to write the cube root as a fractional exponent. So it's 5 to the 1/3, right? Cube root as an exponent is an exponent of 1/3. Once you have the exponent, you can use the power property. So it's 1/3 log base 2 of 5. Oh. Do you know why they had to put the dot here? Because if you typed it, the computer won't recognize that you didn't write blog. The computer won't see it as b times log. The computer sees it as a blog. Because it knows the word block, so it assumes it's a block instead of b times log. I was wondering why we put a dot there. Alright, ready? Am I moving too fast? Person watching the video says, no, keep going. It's awesome. Alright, so here, you have multiplication twice, right? You have multiplication twice. So you're going to write log base 4 of A plus log base 4 of B plus log base 4 of C. Right? All the multiplication turns into addition. And you make them separate logs. All the multiplication turns into addition, and you make them separate logs. And remember, the base of the log will not matter today. Today. Eventually. It'll matter tomorrow. But not much.
Is it going to be like what we did?
Easy. Alright, ready? D. Alright, what are we doing here? Okay, so first thing I'm going to deal with is that multiplication. I'm dealing with the multiplication. So it'll be log base 5 of 7 plus, right? I'm changing the multiplication to addition. Log base 5 of 12 to the third power. But I still have an exponent. Right? One of the things that confuses students in this is, when do I stop? When am I done? Okay? I'll address that in this one. So log base 5 of 7, that doesn't change. But the exponent of 3 comes forward, becomes a coefficient. You know you're done when you only have one thing living inside of a log. So this is a 12 inside of the log. This is a 7 inside of a log. So this part was done. The log base 5 of 7 was done. The log base 5 of 12 to the third was not finished because it's two numbers, 12 and a 3. That's got to move out. Go ahead.
Originally what we did at the top.
Yes.
So
But we're doing a combination of them, right? So this one was a combination of the product property and the power property.
So why would C like log log 4
Right? It was A times B times C. So I did them separately. Log base 4 of
never
A.
mind, I wrote it wrong. I was about to ask why you didn't do that, but I wrote it.
Okay, ready for E? Although I'm not on B anymore. Alright, here comes E. So this is our first fraction. We're going to rewrite this as log base 3 of x to the 6 minus log base 3 of y. So I still have an exponent to deal with, so I'm going to move that forward. So it's 6 log base 3 of x minus log base 3 of y. By the way, if you skip any of these steps, great. That's fine. Some of you are going to see these, like you do, after several of these, you'll start seeing a pattern and you'll just spit them out. Okay? Ready for F? No. Alright, ready for F? Okay, this is a reminder of how to deal with this kind of exponent. Andy, do you remember how to rewrite this as an exponent?
1/3.
Try it again. I have a 2.
2/3.
2/3. That's going to be 2/3. Alright. So don't write this as cube root of something squared. Just write it as 2/3. And then we're going to just bring the 2/3 forward. Oh no. I forgot to say something.
What? Oh, what?
Alright, so I'm going to do it backwards. So I'm going to start with this one.
Do what backwards?
Alright, so sometimes when we have a fraction like this, especially if the computer is generating the answers, it will write it like this. 2 log 3 of 11 over 3, like that.
Ew. Yeah.
I agree.
So you want us to write it like
No. I prefer this way, but you need to be able to recognize that this is the same thing. Right? But some people like this way. Both of them are correct. You don't lose points for one or the other. They're equivalent as far as I'm concerned. No, they're equivalent as far as anybody's concerned, not just me. Alright? But the computer can only think this way. The computer thinks this way.
that one don't look that bad.
Alright, see if you can find another one where I can rewrite it like this. We've already done 2 of them. The first one. So the first one, the computer will write like this. Log base 6 of 17 over 2.
The first one, the second, right?
A. And B. So B would be log base 2 of 5 over 3.
Oh, I get what, okay.
Right. All they're doing is taking that number and just putting it under the log. Alright.
Okay, makes sense.
Okay? Alright. G. Okay, so we have a couple exponents to deal with. So you got to be careful with parentheses in this one. So there's a 2 exponent for the whole thing, so I bring that forward. And that's log base 6 of 7 over 10 to the 4th. And when I write this again, I need the parentheses because of this fraction that I'm going to separate. So it's log base 6 of 7 minus log base 6 of 10 to the 4th. I'm still not done. Why not? I have this exponent. Alright, so I'm going to scooch it over here. So it's going to be 2 parentheses log base 6 of 7 minus 4 log base 6 of 10. Now, if you distribute the 2, that is perfectly okay. But I also accept this answer, right? Remember the rule of when you're done with the logs is when there's only one thing inside the log. You can have a bunch of different logs, but as long as there's only one number inside the log, as far as I'm concerned, you're done. So I don't care if you distribute that 2 or not. In fact, I'd rather you didn't. Yeah, that's right like that. But if you did, there's nothing wrong with that. Alright? Example H. Ready? Example H. So I'm going to skip some steps here. Log base 9. So C to the 3rd. This is multiplication, so I'm going to put a plus sign between them. Log base 9. I'm not going to write square root this time. Remember what square root stood for? 1/2. So I'm going to write AB to the 1/2. Now let's start dealing with the exponents. So it's going to be 3 log base 9 of C. So I bring down the 1/2. It's log base 9 of AB. Am I done? Hello?
No.
I'm looking.
No. Why not, Tyrese? Good job.
Because you got the A and B.
The AB. Good job.
Wrong.
So I'm going to need parentheses because that 1/2 has to cover both of them that's coming out. So it's log base 9 of A plus log base 9 of B. But do you know what the computer is going to generate as an answer?
You want to know?
It's going to be 3 log 9 of C plus log 9 of C over 2 plus log 9 of B over 2. So that's what the... I am okay with either answer. The computer is going to generate the second answer. If you stop at the first one, I am okay with that. But if you want to go to the second one, it'll probably be easier to check your answers. because we're going to use a computer generated answer.
It's right there.
Right, Maya?
Yes. I
Oh.
already copied it. I just don't.
Okay.
Look.
I believe you. All right, ready? Last is 6 examples for today. Example 2A. Example 2A. So this one we're going the opposite direction. We're taking that log and writing everything inside of the log. So example A is really short. All you're going to do is bring the coefficient up as an exponent. So that'll be log base 8 of x squared. That's it. That's all you're doing there. You're just moving that coefficient up as an exponent. Ready for B?
Yes. Yes.
All right, B. Now, so for these questions, when do you stop? You stop when you have only one log and everything is inside of that one log. So here, first thing I'm going to do is deal with this coefficient. So that'll be log base 5 of x plus log base 5 of y squared, right? I take that coefficient, turn it into an exponent. Now, I deal with this addition. So that's going to be log base 5 of xy squared. I have one log and everything is inside of that log. So that's how I know I'm finished.
What's the real life purpose?
Logarithms
Oh, I
are,
know.
do you remember? The 2 examples I gave was the Richter scale and pH, the acid levels or base levels. Right, that pH scale is a logarithmic scale. Do you know what a slide ruler is? Well, a slide ruler was the tool they used before they had calculators.
Oh, it's that, yeah.
And slide rulers use a logarithmic scale. So this is actually a very useful tool in doing calculations, especially when the numbers are huge. That's why the Richter scale is a logarithmic scale. Because when you talk about moving land masses, that's a lot. Right? It makes big numbers smaller.
Can I use the rest?
You may. Alright, example C. You're going to move the coefficient up forward, or I'm sorry, as an exponent, so it's log base 3 of 8 to the 6 minus log base 3 of 7 to the 5th. So I move the coefficients up as exponents. Now I'm going to write that as a fraction. 8 to the 6 over 7 to the 5th. Everything's inside of one log, so I'm done.
How do I know if 8's gonna go over the 7, Ron?
Alright? The 7 has a minus in front of it, so that's got to go to the bottom. 8 is positive, so that's going to go up top.
What if they're both negative?
If they're both negative, you put both of them in the denominator, and if there's nothing in the numerator, you put a 1.
Is that very likely or not?
No, that's a good question, Tyrese.
On the homework it says, for number 6, it says LN.
Right?
It's hard.
Example E is ln. We'll get to that. Okay. Ready? Moving to D. Alright, so I have a coefficient, so I'm going to write it as an exponent. So it's log base 8 of 10 plus log base 8 of 7 to the half. But what is 7 to the half the same as? Square root. So, first thing I'm going to do is just get rid of the addition, make it multiplication. So it would be 10, but I'm going to get square root of 7.
Bless you, Mom. Bless you.
Bless you. And that's the answer, because everything is in one log. Ready? We're almost done. 2 more examples.
I don't like this.
Alright. So this looks weird because you see ln. ln is just another log. This is the most commonly used log. If you look at your calculator, remember you look at your calculator? You have a log and you have an ln. They're both logs. ln is log base e. That's why the shift version is e to the x. Log without a number is log base 10. That's why there's a 10 to the x up there. Okay? So if you see a log and there's no number, that's another place where you assume some number. In that example, you assume it's a 10. You okay? You give me a dirty look.
What do you mean when there's no number?
Okay? Sometimes they will write, oops, no on the back. Like they will write log of 6, right? So they won't write a number here.
Oh.
When they don't write a number there, that's 10. Another weird assumption. If you don't see a number, you assume it's 10. That's true for log. Alright. So E, you can just say log, but this is natural log. ln is natural log. I don't know why they call it that. It's log base E. But I just say log. So here I'm going to use the exponent rule. So I'm going to bring the 2 up, bring the 3 up, and bring the 8 up.
Wait, do you only
How
bring
you
the
got
first
this?
number?
Huh?
You only bring the number that's
Oh,
in front
this
of
is
the
minus
number.
it.
Right? There's still minuses. I haven't changed it yet. But remember what Tyrese asked earlier. How do you know which one goes up on top and which one goes on the bottom? This one's an important one to make that assumption or make that distinction. Right? So 6 has no negative sign in the front. So that's going to go in the numerator. The other 2 have minuses in the front. They go into the denominator.
So like if it's ln, it's always one.
It's always
Oh,
one.
never mind. I'm sorry. Never
No
mind.
problem. Last example.
The thing in the front goes to the exponent.
Is the back for tomorrow?
The back is for tomorrow.
Okay.
Now tomorrow you're going to say, where in the world would you use this? And I'm going to say, I don't know. But I like those problems.
Are they easy?
I answered that question today. Richter scale. Remember the seismic scale? When earthquakes happen? The Richter scale. Also the pH scale of acid. Alright, here we go. Natural log of 5. Natural log. So what does 1/2 become?
Square root.
Square root. So it's square root of x minus natural log of 7 squared. So same thing. When the Tyrese asked the question, which ones go on top, which one goes on the bottom? So which one of these are going to go on top?
The positives.
The positive.
The 5 and the square root of x.
Square root. Yeah.
And the 7 squared is going to go on the bottom because of that minus sign.
Yes.
There you go. And that's the answer. And that is the end of the lecture.
When do we have a test?
On everything, I don't know.
Wait, what do you mean?
But just this stuff, Monday.